then this is, we got an error, we got a sum square. Okay, and this is the correct answer. If you do not run two-way and without the interaction, then you use one-way ANOVA, you will get this result. If you take this way away, like a one-way ANOVA, and for each level, 6 observation, only one-way ANOVA, you will get this result. You can compare these two tables. This is not correct, okay? This is correct. If this is block, so if you do not block, like this one, the sum square of block will come to error term. The degree of freedom block will come to error term. The mean square of error term will become bigger, bigger. The system is always the same. The sum square, degree of freedom, the mean square. So the F value of the system gets small because the mean square for error term becomes. You can see this is much bigger, this is smaller. The F value for this one is this one divided by this one. So this one is bigger, this one. No, this one. This one is bigger. Divided by this one. Here, the same mean square divided by the smaller error term for error term. This is correct. So the F value is much bigger, so P value is significant. If you do not take the block away from the error term, like this one, then everything of the error block will come to error. So error like a black hole in the space. So the block sum square will come to 30 plus 19 is 49. The degree of freedom 5 plus 10 is 15. You say, okay, the degree of freedom increased by 5, but the sum square increased by what? Much bigger. So the mean square become bigger. The denominator in this case become bigger. So the F value become smaller, the P value become bigger. You can see the effect if you do not leave the block in the ANOVA table. So covariate just like block. So you need to leave the covariate like an involvement in my case. Here, this is the covariate like a block. Okay. So when you conduct your experiment, you got to think about some variable. We call this is a covariate, will affect the response type, response variable, and you need to control it just like block. You need to control block. Otherwise, the result is totally different. I don't know whether you understand or not. Okay, I have already finished my lecture. So this is correct. This is not correct. This is one way ANOVA, it's not correct. But maybe you ask me, when did you need a concern block in your experiment? In this case, you cannot use different air traffic controller when you conduct your experiment. You say, how come? Because people will affect the result. So you need to control people. You need to use same controller you run the experiment. For system A, B, C, the same people. Okay. In that case, you need a block. Understand? Okay, this is ANOVA. I plot the two-way ANOVA. Do I plot three-way ANOVA for you? The interaction? Do I? The way I teach you is totally different from most professors because I teach you is very comprehensive. You never learn this kind of in any course. Next semester, I'm going to offer course for PhD program. Okay, the definition for the variable here. Okay, this phi is independent variable, so we can have a five-way ANOVA. And for x1 is customer type, there are three types. 1, 2, 3. For x2 is industry type, there are two types. Magazine or newspaper. For x3 is company size. There are two, 0 and 1. Okay. 0, 1, 0 means small company. The important number is less than 500. X4 is region. Your customer is located in North America or outside North America. 0 or 1. X5 is the way how to deliver your product to your customer. Indirect through broker, through the mediator, or direct to customer, 0 or 1. The dependent variable in this case, I will use this one. From 0 to 100. Okay, five-way ANOVA. Five-way ANOVA. I jump from two-way ANOVA to five-way ANOVA. The model is 4 factorial. What am I going to do? You see, total number is 200, 200, 200, 200. What happened to here? What happened to here? How come there are so many zeros? Five-way ANOVA. How many main effects? How many? 5. How many two-way interactions? 10. How many three-way interactions? How many? It's very complicated model. How many four-way interactions? 5. How many five-way interactions? How come this data is 0? Because there are only 200 data, and you have so many combinations. That's impossible. How many combinations we have? 3 times 16. Total is 48. And some of the combination is no data, only 1 data, or 0 data. So that's why the sum square is 0. So what are you going to do? What are you going to do? This is the way you analyze your complex model, okay? It's not in the textbook. Textbook never mentioned how to analyze so complicated model. Only in the class, okay? So I will do, the way I will do is, I will specify my model. You have 5 independent variables, so total you will have a 5 interaction. So in this case, just first, the first time you specify main effect only. Then the model will be more complicated. Simple. You see? All these are actually this X4 is not significant. So this is. I tell you what, we don't care about the sum square, we don't care about degree of beta, we don't care about mean square, we don't care about f, we only care about the p value, okay? So will you spend your time to learn how to calculate all the details data? No, you don't. You just look at the output. Can you study the higher interaction? If I were you, I would take the X4 from the model. Now again, because X4 is not significant. So now we have a how many model? 4-way instead of 5-way. How about 5?
Not significant.
You can take it away. It's not significant. No impact. So we reduce from 5 to 4 to 3. So we become 3-way interaction. Great. Each one of them are significant. But we are going to run the 2-way, 3-way interaction for smaller number of independent layers. So now we can come back to 4 factorial. Okay? Then you can it's too bad. This is not significant. So I'm going to take a 3-way interaction away from the one. So powerful, okay? You can try 2-way. No 3-way. Let's see. This is not significant. I will take this away first, the X1 and X2. So this is very useful, okay? You reduce your model to simplify model. You never learned this before? No. You should ask your tuition back from school.
Good.
I will take this one by one, not take all of them. You can take this 2 and 3. So this is so powerful, custom. You can define 1-way, 2-way, okay? It's imagined, okay, I will read this. So in this case, I will plot the interaction plot, X1 and X3. X2, I will read it because it's significant. I will not conduct a possible test for X1 and X3 because their interaction is significant. If I use alpha 10%, 0.110, then it's significant. So what I'm going to do is I will plot X1 and X3. Okay. Then I will, because the interaction, I don't care about X1 and X1 and X3. I care about X2 and the X1. I don't care about X1 and X3 because their interaction is significant. And I do need to look at the X2. Okay. Then I don't need the post homogeneous because X2 only 2 labels. If there are more than 3 labels, you need to conduct a homogeneous test for 3 labels. Okay. So everything is all set. So I'm going to look at this one. So the higher the value of the X22, this is the use level for your customer, from your customer. This is the highest one. Okay. For large company, they use much more. And the intention, you can see what's what's the definition for intention? What's the intention? The definition for intention?
If one changes, the other also changes, or the
Not so precise. Okay, they say the difference between small company and large company. Okay, the difference for each level of the other independent variable is the same. If they are the same, the difference is the same. There's no interaction, but it seems not. You can see for new company do business with you less than 1 year. If the company is large company, the difference between large company and small company, the purchase level is so much. But when they become 1 and 5 years customer, the difference between large company and small company becomes bigger, much bigger. You can see, so that's the interaction. But however, when they become the over 5 years customer, the difference between small company and big company is the smallest one compared with this one. So that's the interaction. So what's your strategy from this output? What's your recommendation to the company? If you are the analysis department, what will you suggest to the company?
1 to 5 years.
Try to maintain your customer over 5 years. Okay? And it doesn't matter whether the company is small or big company, they always use a lot. They always purchase a lot of product from our company. How about for the X2? Here, you can see. The X2 is significant. The X2 is significant. And we can see, we don't need to conduct a post-hoc test because there are only 2 levels. We know they are different. The magazine company, they use more than the newspaper. There are only 2 labels. Okay. And I'm going to show you how to plot the 3-way interaction. Now we have only 2-way interaction. I remember in this case, okay, I need to take everything away, because I run my model. Before you run the new model, okay, I want to see 3-way interaction. Good. This is what I'm looking for. 3-way interaction is significant. So I don't care about the rest of the 2-way or 1-way. This interaction is significant. How come it feels so boring? No patient. You bother me, okay? It's supposed you so interesting about what I teach you because you never learned before. You don't learn this kind of technique everywhere. I don't think you can learn everywhere. Okay, this is the only place you can learn. You should open your eye, open your mouth, pay attention, not feel so boring. The attitude is not good. You are a teacher, and you can tell. When you teach on the stage, you want everyone eager to learn. Okay, 3-way interaction. Okay, I will try. So once the 3-way interaction is significant, you don't need to analyze or plot 2-way interaction problem. Okay, because it's the higher rank. Okay, I'm going to plot. Okay. will plot this one because there are 3 labels. So I will reduce my plot. I will put this one here. I will put this one here. Okay. If I do the other way, okay. What will happen? What will happen? If I do the separate plot, what am I going to do? You will see what's going on. Hey. Can you tell me how many plots we have for this one?
2,
How many plots?
2,
How many plots?
3.
3? How many plots? Nobody know? 1, 2, 3, 1, 2, 4. 4 is separate plot. So how many labels have 4?
2.
2. Okay? And for the interaction plot, just like this one. Okay? So there are 2 plots. How about this one?
Same.
How many plots we have?
2.
3.
3.
Because the x1 the 1, 2, 3.
Oh.
And the plot will look like 2 by 2. Okay, now 3 by 2. So which one you prefer? I show you. Which one is better? Here, you will see. Okay. There are 2 plots. This is x4 equals 0. 3 by 2 plot. The second plot, x4 equal 1. The other option, 3 plot. You can see x1 equal 1, 2 by 2 plot.
Oh.
Use your imagination. Which one is better? This one or this one?
Take notes.
First one.
More easy.
This is simple. Okay, always use less plot. 3-way. How about 4-way? If 4-way interaction is significant, what are you going to do? If 4-way interaction, and I should check the model. Hope it's significant. It's close, okay? It's close. If alpha is 10%, 0.10 is significant. How are you going to plot? If you remember in the plot we have only 3 icons. So what are you going to do? Did you see my file? Did you see my file? I set x4 to 2 files. x4 equals 0 and x4 equal 1. You need to separate your file. Because for each file, this is x4. Everything is equal 0. And I'm going to use this one, conduct 3-way interaction. Should be significant. Okay, 3-way interaction is significant. x4 equals 0. And I'm going to plot. Again, this is 3-way, not include x4, because x4 is already separated to 5. So plot, Okay, here. How many products you have? Two. And then this one is 0 because there is no data in this case. So how many total products we are going to have? So this is x4 equals 0. We have a 2 product. This one and this one. This one is x1, x3 equals 0. And this is x1, the line is x2. Okay? The other problem. This is x1, this is x2. x1. How about x4? Equal 1. You have another two problems. So total you have. If five-way injection is significant, how are you going to do? Separate your file to x5 0 and 1. Okay, so total how many products you have? 1, 2, 3, 4, 8. You need to separate your file. So you have 005, 015, 105, 115. Okay. So you need to separate your 200 data to 4 files. As a student, you know when the professor or teacher teach you one thing, you need to know expand to 3. Okay. That's what I teach my daughter. You know, when she was 3 years old, I tell, can we play this one again? Okay, I told her I will show this one, and that's her guess. I'm going to, and we say, I told her this way, and I will put this way, and you will put this. So we use 3 steps or 4 steps ahead. That's the way you teach your children. Okay. The more you learn, the more smart you are, the more smart your children will be. As a professor, teach you so much. You know how to expand? Did you know how to expand? I should be the national treasure. Sure. Is anyone teach you like this way? No. Just teach you 2 way ANOVA. That's it. I'm going home. I'm done. And you never know what I'm going to do. But I show you 5-way, from 3-way, 4-way, 5-way, and if 5-way, because the product only 3 variables, and you need if 5-way, you need to separate your file to 4 different files, and for each file, you need to have a product, 3-way product. Okay? Maybe. And next week I'm going to talk about the regression. And regression is very. I think some of you will. In finance department, you use a lot of regression. Okay? Especially for those departments in economy, they use a lot of regression. But for our department, we use different way. Okay, we use ANOVA, we use SEM. Okay, and we have 4 more weeks. And the end of the December, I told my 2 group of undergraduate students, they will come here to show you. So we have 3 more weeks to I will teach you about the regression. There are 3 chapters, chapter 14, 13, and 15, 16. Simple linear regression, multiple linear regression, and more complicated model. And you will have a final test on January 9th. Oh, when are you going to present?
Can I do it in December, during any week in December, because
How about next week? Because we already, no, we need to finish regression. I think how about the 3rd week?
yeah, okay.
The 3rd week of December, because we already talked about regression.
No problem.
Okay. The double standard.
Yes, double standards.
Okay. See you next week. We are going to move to